Uh, point. Use the okay. So so some new ones is going to be the double angle identities, and we have for sine and for cosine. For the one for sine, it is going to be sine. Again, the book uses u's and v's. I'm going to use x's and y's when necessary. So sine of 2x is equal to 2 times sine of x times cosine of x. The cosine example, identity, is the cosine of 2x. It has three different equations. You can have one that is cosine squared x minus sine squared x. You have one that's 2 cosine squared x minus 1. And you have 1 minus 2 sine squared x. All the same and easier than others depending on what information is given to us. And I'll make sure to do a few each one. All right. And then we also have a tangent one as well. And it is tan of 2x is equal to 2 times tan of x over 1 minus tan squared of x. All right. So those are your double angle identities. So anytime you're looking for cosine, sine, or tangent of 2x or twice the angle, we can use these formulas to calculate that to get the correct answer, given information that we are provided with. The next set are going to be your power reducing identities. And the one for sine is going to be sine squared x. So if I want to reduce it from a squared to a single power, this will be a 1 minus cosine of 2x divided by 2. So this now goes from the power of 2 to now a single power. So that's what a power reducing identity would do. For cosine, a cosine squared x will produce a 1 plus cosine 2x divided by 2. And then our tangent will be tan squared x would equal 1 minus cosine 2x divided by 1 plus cosine 2x. All right, so those are your power reducing. So if you're ever asked to reduce the power of something, we can use this to simplify or maybe even expand it to reduce its exponent. A lot of times we can do that just to help solve because now we have double angles in here. So then we can pull those equations into this to calculate a potentially hard question. All right, the next set is your half angle identities. For sine, we have sine of x divided by 2 will equal the plus or minus square root of 1 minus cosine x divided by 2. The cosine identity will be cosine of x over 2 will equal plus or minus the square root of 1 plus cosine of x divided by 2. And then your tangent identity will be tan of x divided by 2 will equal 1 minus cosine x over sine x, or it can be sine x divided by 1 plus cosine x, just depending on what information we have. One might be easier looking than the other. And then the main part of this section here is the product to sum identities. So if I have something that's being multiplied, it might be easier to write it as a addition question so that I can find my answer a little bit easier. So the ones we have here are not generated just for sines and cosines and tangents, but we have, if we have a sine x times a cosine y, it will equal 1/2 of sine x plus y plus sine x minus y. We can have a cosine x times sine y. That would equal 1/2 of sine x plus y minus sine of x minus y. We could have a sine x times a sine y, and that will be 1/2 of cosine x minus y minus cosine of x plus y. We can also have a cosine x times a cosine y, and that will equal a 1/2 cosine x plus y plus a cosine x minus y. All right, so that's the product to sum. So if you have a multiplication problem that we can't figure out, we can turn it into this sum and potentially actually figure it out. The last one is a sum to product. And sometimes when it's being added, sometimes it's easier to write it as a product. And they are, I could have sine x plus sine y, and that would just equal 2 times sine of x plus y divided by 2 times cosine of x minus y divided by 2. I can also have sine x minus sine y equals 2 times cosine of x plus y divided by 2 times sine of x minus y divided by 2. I can also have cosine x plus cosine y, and that would just equal 2 cosine of x plus y divided by 2 times sine let me check, because that looks exactly the same. Oh, all right, cool. Almost wrote that wrong. It's actually 2 times cosine of this times cosine of x minus y divided by 2. And then the last one is cosine x minus cosine y would equal -2 sine of x plus y divided by 2 times sine of x minus y divided by 2. So I know it looks more complicated when you rewrite it like that, but sometimes the left, we just can't figure it out. We can rewrite it as the right and actually find it exactly on the unit circle. All right, so that's pretty much everything that is in the section of 8.3. So now I just want to kind of go over a few of the type of homework questions you could see to make sure you have everything you need to be successful on this section. So first I want to look at number 2. Number 2 states that tan x is equal to -4 and sine x is negative. We're going to find all three here, so I need to determine what cosine of 2x is, what sine of 2x is, and what is tangent of 2x. All right, for starters, you might be asking, what information can I do with this? Well, let's look back at what cosine 2x actually equals. So cosine 2x is equal to three things. It doesn't matter which one you use. I'm just going to use the first one. Is cosine squared x minus sine squared x. So for me to solve this, I need to know what cosine and sine are. And I'm only given tangent. So as a side work here, what you need to do is build your triangle so you can solve for your missing angles. We'll let this guy be x. Remember, tangent is TOA, so it's going to be opposite, which is -4. Actually, in this case, hold on. We'll talk about that in just a second. It'll be 4, and then this will be a 1. And then to figure this out, it would just be 4 squared plus 1 squared equals c squared. So that would just be the square root of 17. So if I call this the square root of 17, you might be asking, well, where does the negative go? Sine is negative. So remember that tangent is sine over cosine. So therefore, the sine, which will be the negative, will in fact go to the 4. Had this been cosine is negative, then it would be a -1 here. Note that when sine is a negative, it is either located here or here. But since tangent is a negative, we know we must be located in the 4th quadrant. That's going to help us get the right signs to the right numbers. When it comes to the C is always positive. So now I'm ready to plug this in. So my cosine squared here, this would be SOHCAHTOA, so that's adjacent over the hypotenuse. So that's going to be 1 over the square root of 17 squared. Don't worry about rationalizing it right now. Do that part at the very end if needed. Sine will be -4 divided by the square root of 17 squared. We work this out, apply it to both. We get 1 over 17 minus 16 over 17. And when you work that out, that becomes -15 over 17. Right? So therefore, again, with that little bit of information, we're able to find the double angle of cosine, which is just -15 over 17. All right. So with that said, now let's find the sine double angle. And this one was a 2 sine x times cosine x. So just like up here, I'm going to do the same thing and plug in my information. We now know sine x is just going to be -4 over the square root of 17 times cosine of x, which we now know is 1 over the square root of 17. So again, do the rationalization at the end, save yourself some work. Because what I can see here, I multiply straight across. So 2 times -4 times 1 gives me -8. Square root of 17 times square root of 17 just gives me 17. So I now have the double angle for sine, which is -8 over 17. We're going to continue this pattern as well to do the tangent of 2x, the double angle of tangent. And that was written as 2 tan x over 1 minus tan squared x. Again, we're given tan, so we can do all the work right there. So it's going to be 2 times -4 over 1 minus -4 squared. So this just becomes -8 over 1 minus 16, which will be negative 8 over negative 15, which gives us a positive 8 over 15. All right. So hopefully that makes a little bit more sense on how we utilize these equations. And of course, I want to make sure I go over plenty of examples. So let's do number 3 next. But on this one, I'm just going to look for cosine of 2x. The first one gives you all the examples. This one, you can kind of figure the rest of them out. So we are given this information here. Cosine x is equal to negative 2 over the square root of 6. And you are told that sine x is positive. So when we're building our triangle here, if cosine's negative and sine is positive, that can only happen in quadrant 2. All right, so when I do cosine, I know this is ka. So here is my x here. So my adjacent will be the negative 2, which deals with the x value, and then the square root of 6. So I know that this answer has to be positive. So that's going to be a squared plus negative 2 squared equals the square root of 6 squared. Those cancel, giving me 6. So I get a squared plus 4. Subtract the 4 over, so I get a squared equals 2. So a would equal the square root of 2. So I now have I need. And again, I'm just going to hyper focus on cosine of 2x. I feel that you can now come up with sine and tangent. I just want to make sure we're doing enough different type of problems on this end so you can see how to do the side work. Again, cosine of 2x can be used in any one of them. Again, I always default to the first one unless I feel that another one would be easier. So again, that was cosine squared x minus sine squared x. So my cosine was already given to me, so that's going to be negative 2 over the square root of 6 squared minus, now I need to come up with my sine. Sine is so that's going to be the square root of 2 over the square root of 6 squared. So when I work this out, apply it to both. So that's going to give me 4 over 6, because again, I squared the actual number, but I cancel the square root, minus 2 over 6. And when I do that, I get 2 over 6, which is 1/3. All right, and you do the same type of process for your sine and cosine. Let's do one more of this type. So let's look at number 4. This time I tell you that sine x is equal to 1 over the square root of 5, and tangent of x is positive. Well, for tangent to be positive, either both sine and cosine are positive or both sine and cosine are negative. Since sine is a positive, that tells me cosine will be positive as well, and that only happens in the first quadrant. So when I build my triangle, I know all my numbers are going to be a positive. So again, sine is my so my opposite will be 1, my hypotenuse will be 5. I've said this like in every video, but it does not matter where the x goes. If you do it here and line this up as your opposite and adjacent, you'll still get the same conclusion. All right, to do this side work now, that's going to be 1 squared plus b squared equals the square root of 5 squared. Gives me 1 plus b squared equals 5. Subtract the 1, so I get b squared equals 4, so that must mean that b equals 2. Now that I have all of my information and I know everything is positive, again, I'm just going to hyper focus on cosine of 2x, but know that you can easily find the rest. And again, I'm going to default to that first example, which is cosine squared x minus sine squared x. And when I do my cosine here, that's going to be adjacent over the hypotenuse. So that's going to be 2 over the square root of 5 squared minus the given sine already. So that's 1 over the square root of 5 squared. Apply it to everything. So we get 4 over 5 minus 1 over 5, which will then give us 3/5. All right. All right, so that should be enough examples for that. Let's move on to the power reducing identities. So let's look at number 7. So it says use a power reducing identity to rewrite the given expression as directed. So number 7 says we want to rewrite sine 3x in terms containing only first powers of sines and cosines. Okay, so when looking at my sine here, I only have one for sine squared. So this is what we can do. Sine cubed is the same thing as sine x times sine squared x. Sine is a power of 1, but sine squared is not, and I can use my identity to change that up. So that now gives me sine x times my square identity, which is 1 minus cosine of 2x divided by 2. Right? I'm okay with you ending here, but obviously this is an online course and you must write it like they want it. So the only extra step you need to do is take the sine x and distribute it across. So this is now going to give me sine x minus sine x times cosine 2x all divided by 2. And then that would be their most reduced answer. And that's it. So everything is in powers of 1. You've done what was accomplished of you. Let's look at another example to make sure you fully understand what we just did. So let's look at number 8. Number 8 asks you to rewrite sine 4x in terms containing only first powers of cosine. So just like before when we separated sine cubed x, we can do the same thing here. I'm going to separate it as sine squared x because I have an identity for my sine squared for both of them. And when I do that, I will get 1 minus cosine 2x divided by 2 times 1 minus cosine 2x divided by 2. Right? Now, the only difference here is they do want you to actually multiply this out, but note that this is a binomial and must be distributed. So I'm going to rewrite this as 1 minus cosine 2x times 1 minus cosine 2x divided by 4. All right. This is where it's going to get interesting. Let's see what we can do here, because we just want it in terms of cosine. I don't know if that will help me go backwards or forwards with that. I do have a double angle for cosine, but I have for cosine squared sine squared. Let's just start there. So we'll do this following here. So that would be 1 minus cosine 2x minus cosine 2x plus cosine 2x squared, all divided by 4. Now I need this to be a single power using sine, or using cosine. So I can rewrite this as 1 minus 2 cosine of 2x plus, let's see if we can make this look a little bit cleaner. So this right here, so we have 3 options. Keep it in terms of sine. That would give us a 4. Let's try that technique. So we know cosine of 2x I'm gonna write, I want to plug in 2 cosine squared x minus 1. So again, the question stated that it wanted me to keep it in terms of cosine. So now when I do this, I'm going to fold that one out again, so that when I do that, this will give me a 4 cosine to the 4x minus 2 cosine. Man, I'm starting to wonder if there's an easier path. First power. We could have stopped here. Like, this is where we were at. Hmm. Let's see. So then again, so if we kept this going, this would be a squared and then 2ab. So that'd be -4. Let's rewrite that real quick. So that'd be -4 cosine squared x plus 1. All of this divided by 4. The issue is they want us to write this in first power of cosines. But if I do that, I'm going to be at the same situation I was just at up here. So why are we doing this so many times? Let's see what we can get from the book. All right, so the example they got here, they got 1 minus 2 cosine. That's where we're at right now at this stage. Okay, that's definitely an easier process because we're gonna have to repeat this 4 or 5 times before we get to that point. So let's not go too far back, but we'll go right here, and this will be 1 minus 2 cosine 2x, and we'll keep this as cosine squared 2x divided by 4. And what they did here is then they turned this right here. They factored out this 1/4, which I do like that idea. And they said 1 minus 2 cosine 2x. And this cosine squared x, you can still use the double angle, but when you square it, it becomes 1 plus cosine 4x divided by 2. All right, so then we can have something simple like that. And then all we got to do is pretty much, we need to kind of combine this as one giant fraction. So what we'll do is we will put a 2 here and multiply this entire thing by 2 as well. So we'll now get 1/4. And this will now become 2 minus 4 cosine 2x plus 1 plus cosine 4x, all divided by 2. And then when we simplify this now, we can say this is all going to be an 8. Combine this will be a 3 minus 4 cosine 2x plus a cosine 4x. All right, so there's right there. So this technique from here to here to here is a good note to make our life a little bit simpler than where we were heading. So I'm definitely glad we did this problem. So let's do another one to regain our momentum. So let's look at number 11. This one says rewrite tan power 4x times sine x, containing only first powers of sines and cosines? Well, for starters, I'm going to turn this tan 4 to tan squared x times tan squared x times sine. And then I'm going to use that power reducing identity for squared to give me 1 minus cosine 2x over 1 plus cosine 2x. And since it's really being done twice, I could write it as a square, but I'm going to need to fold this out. So I'm going to write this again. 1 minus cosine 2x, 1 plus cosine 2x times this sine x. Fold the top and fold the bottom. This is what we get then after that. So that would be 1. This will be a negative 2 cosine 2x, and then a positive cosine squared 2x, divided by 1 plus 2 cosine 2x, plus cosine squared 2x. All right, and then now we times sine x. We now know what this equals, so we're going to say this is now 1 minus 2 cosine 2x plus r, from example 3, where this got pulled from. Again, this will be 1 plus the cosine 4x over 2. And then this will be 1 plus 2 cosine 2x plus 1 plus cosine 4x divided by 2 times my sine x right there. All right, so we're just about there. The issue is they definitely want you to simplify this one to get it down to a little bit prettier numbers. So to do that, what I can do is I can multiply the top and bottom by 2, and that's the same thing as multiplying by 1. So that's what I'm going to do here. I'm going to multiply by 2 and 2. And what's going to happen is this now becomes a 2 minus 2 cosine 2x plus this 2 will cancel this 2, so it'll leave me with just 1 plus cosine 4x. Again, as long as I do whatever I do to the top to the bottom, it's a legal move. So 2 plus, oh, that should have been a 4. Just 2 times 2 is 4. And then 2 times 2 would be 4 cosine 2x. And again, this would cancel, leaving me with plus 1 plus cosine of 4x, all times sine x. They do want you to distribute this is where we're at. And when you distribute that sine, man, it seems like it's so much extra work. See, hold on. So if we do this right here, this will give us 2 minus 4. And if you're dividing both of them by 2, keep change flip, the 2's will cancel. So yes, this is where we're at. All right, so yeah, so what we can do is we can just rewrite this then as, and what I'm gonna do is I'm gonna combine 1 and 2 and multiply this sine. So that's gonna become 3 sine x minus 4 cosine 2x plus cosine 4x, all divided by 3 sine x plus 4 cosine 2x plus, oh, I totally forgot the signs in there. I gotta write the signs. See, again, that just makes it seem like it just expands it too much. Anyways, so this would be sine x here plus cosine 4x sine x. And then this would be sine, oh no, I won't need it on the bottom. That's it. That's what I was looking at. I just gotta multiply it to the top. So again, so this will just be a 3 plus 4 cosine 2x plus cosine 4x. And again, to me, these areas here just look a lot better, but this is as far as they want you to go right there. All right, so there we go. So be prepared to write a lot of steps on those questions when we get to them. All right, switch gears now to number 13. It says determine the exact value of each of the following expressions. So we have sine 3 pi 8. And again, the goal is to do this without a calculator. So we kind of want to look at this and go, if we double, can we double it? I don't think we can double it. Can we half it? I don't think we can half it. Can we square it? So you have 3/8. Hmm. Looking at our identities, let's see, what is the product of sum doesn't help us here. So let's look back at example 4 and 5. And I'm thinking it has to do something with the half identities and the double identities. So example 4 and 5. Yes, okay. That's what I was thinking. All right, so if we use the half angle, so let's look at sine real quick. So sine of x divided by 2 is equal to plus or minus the square root of 1 minus cosine x divided by 2. So if we call x and we're saying that this is going to be half that, then that would just be 3 pi fourths. So if we say that this right here is the same thing as 3 pi fourths divided by 2, keep change flip, this does in fact equal 3 pi eighths. And we say that this becomes cosine of 3 pi fourths over 2. We know what cosine 3 pi fourths is. So that will be 1 minus 3 pi fourths. Remember, this is 1, 2. Here's 3 right here. That is negative square root of 2 over 2, comma square root of 2 over 2. So this right here will be negative square root of 2 over 2, all divided by 2. A whole bunch of stuff fine. So 1 plus the square root of 2 over 2 over 2. And so again, I can multiply the top and bottom by 2. And when I do that, I get plus or minus 2 plus the square root of 2, because these will cancel. over 4. And I hope that is as they want you to go. Further if need be. But they are so this will be, where's number 13 at? Determine the exact value. Well, good on both sides of that. All right, so there you go. So there's, all right, so let's do one more of those. That taken care of, and then we'll do the last set of questions that you will see. So this will be 16. So this is going to be tan of 7 pi 12ths. Half a I do. And so when we write out our tangent half angle, it doesn't with I do apologize for that, having the headset issues again, so hopefully it will stay connected this time. All right, so this will be a 1 minus cosine. This is the x value right here. So this will become 1 minus cosine of 7 pi 6 divided by sine of 7 pi 6. Oh, not where I wanted with that. All right, so again, this right here is negative. So this right here would be 1 minus negative square root 3 over 2 over negative 1 half. We get 1 plus square root 3 over 2 over 1 over 2. And again, what I'm going to do is multiply both sides, top and bottom, by 2. And when I do that, I get 2 plus the square root of 3 because they cancel, divided by 1, cancel. Square root of 3 as my final answer. All right. So that's number 16. 7 pi. Well, I guess we just a kind I do apologize. I'm going to keep kind of working with this headset until I can get to work. All right, so the reason this is actually positive is 3 pi 8 is located right here because that's going to be less than half of a pi. So that's why we take the positive version. So when we're looking at this one here, 7 pi 6 is actually going to be, oh, sorry, 7 pi 12, sorry, is actually going to be located in this quadrant here because half of that would be 6 pi 12. And if it's in quadrant 2, tangent is actually a negative. So your final official answer will be negative of this result. You can either distribute the negative or leave it like that. I think that your homework will take either one. But do watch out where the original term falls. That's why we have the plus or minus in our function, because it works either way, but then we got to go back and figure out where did it actually fall. All right. Now let's focus on that product to sum and sum to product questions, and then that will pretty much wrap up this lesson. So a lot to unpack in this section compared to the last two, but definitely give yourself plenty of time to work through these. All right, so number 19 says sine of 3x times cosine of 3x. And it just says use the product to sum identities to rewrite the given expression as a sum or difference. So we're just rewriting. So using our product to sum, this would be your x and your y. So if I have a sine and cosine, I'm just going to rewrite it as 1/2 of sine. Again, this is your x and this is your y. So this will be 3x plus 3x plus sine of 3x minus 3x. So when we work through this, this is 1/2 of sine of 6x plus sine of 0. We know at sine 0, it is equal to 0. So really, we just have 1/2 of sine 6x. Oh, so I know that this is equal to 0. I don't know why we're leaving it there, but they did. So this is the answer that they accepted in your homework, but we know sine of 0 is equal to 0, so we could have simplified that down to this point. I'm assuming they'll take this one as an answer, but note that you could rewrite it as this as well. All right, let's do another one of those. Again, we're just rewriting, so this is definitely a lot quicker of a process here. So number 21 says 5 times cosine of 105 degrees times sine of 15 degrees. That 5, we're just going to move to the outer parts right now and then just work with what the product to sum is here. This is a cosine times sine. And once again, this is your x and this is your y. So this is going to be 1/2 of sine of 105 degrees plus 15 degrees minus sine of 105 degrees minus 15 degrees. So when we work this out, I'm going to go ahead and distribute this here. So this is actually going to give you 5/2 of sine of 120 degrees minus sine of 120 degrees. And before I work it out, let's make sure we don't have to, and we don't. So you can leave it like this. So that's probably why they kept the 0, because we're just rewriting it, not actually simplifying it. And for starters, 105 minus 15 is not 120. That would be 90 degrees. So again, we're just going to leave it like that. We don't have to work it out any further than that. All right, so the next one we need to look at is number 23. So this is going to be sine x plus y times sine of x minus y. All right, so again, this right here is your x and this is your y. So don't be bothered the fact that there's more than one x and y. Just stick to what is given. So sine x times sine y would just be 1/2 of cosine of x plus y minus x plus y minus cosine of x plus y plus x plus y. So when we simplify this, this gives you 1/2. When we distribute this, this would basically just be cosine of 0. Oh, I see the minus there. I did not see that while ago. So let's relook at that real quick. So this will be a minus y, and this will be a minus y. So that would give you x minus x, which will 0 out, but this would be a y minus, turn into a positive y. So y plus y would actually be 2y. This will give me 2x, but then the y's will cancel, so this will be cosine of 2x. And then we just leave it like that. So do watch out for those little things there. They can definitely get you. All right, and then let's look at one more in this direction, and then we'll switch to sum to product. So let's look at number 27. So this will be 2 cosine of pi thirds times sine of pi sixths. So I'm going to have the 2 on the outside, again, focusing on the fact that this is cosine times sine, and this is my x and my y. So cosine times sine would give me a 1/2 sine, like this, sorry, of x plus y. So that's pi thirds plus pi sixths minus sine of pi thirds minus pi sixths. 2 times 1/2 will just go away, so I'll be left really with sine pi thirds times pi sixths. Well, this is the same thing as 2 pi sixths, so that gives me 3 pi sixths. And then this again is the same thing as 2 pi sixths, so this will give me just pi sixths. So to reduce that one more time, that'd be sine of pi halves minus sine of pi sixths. And again, you just leave it like that. We don't actually have to go find the answer. All right, so now to go to that last part there of number 28. And now we're just going to go from sum back to product using the last identities that are in our section here. So that'd be sine pi fourths plus sine 3 pi fourths. So again, recall from the identity itself, this is your x, this is your y. So when I rework this, it will become 2 sine of x plus y. So that's going to be pi fourths plus 3 pi fourths divided by 2 times cosine of pi fourths minus 3 pi fourths divided by 2. So then we'll simplify that out. Pi fourths plus 3 pi fourths is 1 pi. So that becomes pi halves. And then cosine pi fourths minus 3 pi fourths is a negative pi halves divided by 2. So don't forget about that 2 after doing the work on top, because you're going to have to simplify it just one more time. And again, it doesn't ask us to actually go solve it. We're just going to be rewriting this. So this would be just sine pi halves. And then keep change flip, you would get cosine of negative pi fourths. And then you can leave it like that. Well, I say that they do go one more step further. If you remember from the previous section, cosine with the negative of the even odd identities, it just goes back to a positive. So they rewrite this as their final answer as sine pi halves times cosine pi fourths. So even though we got a negative using the even odd identity from 8.2, we can rewrite it like this as our final answer. Let's do a few more of those to make sure you fully have all the examples you need. So let's look at number 30. This will be cosine of 60 degrees plus cosine of 30 degrees. Again, I like to label my stuff so I know exactly where to plug it in. So this is going to be a 2 cosine of 60 degrees plus 30 degrees divided by 2 times cosine of 60 degrees minus 30 degrees divided by 2. So a little bit easier problem. This is going to be cosine 60 plus 30 is 90. 90 divided by 2 is 45 degrees. 60 minus 30 is 30 divided by 2 gives me 15 degrees. And again, we do not have to simplify it. We just had to rewrite it so we can leave it like that. Let's do a couple more. So let's look at number 33. So this is sine 135 degrees minus sine of 15 degrees. Again, this is my x and my y. So when looking at the identity, I see that it's going to be 2 cosine x plus y. So it's going to be 135 plus 15 degrees divided by 2 times sine of 135 degrees minus 15 degrees divided by 2. So we get 2 cosine. 135 plus 15 is 150. And then 150 divided by 2 is 75 degrees. And then We were going so good. All right, so that's 135 minus 15, which is 120 divided by 2. So that would be sine of 60 degrees. And again, we do not have to actually go write out the answers. We can leave it as such. All right, I'm going to stay on this page. Let's do one more, and that's number 35. So this is going to be cosine of 7 pi 6 minus cosine of pi fourths. Again, label your information. This is your x, this is your y. So again, cosine, that would be a negative 2 sine of x plus y. So that's going to be 7 pi 6 plus pi fourths divided by 2 times sine of x minus y. So now this is 7 pi 6 minus pi fourths divided by 2. So we got a little bit more work than we have been doing. This is going to be 12. So that means this right here would be 12, and this will become 14 pi. This would be 12, and then that means that this is 3 pi. Same concept over here. This would be 14 pi, and this is 12. This is 3 pi, and this is 12. So we get 14 plus 3, so that's going to give me sine of 17 pi divided by 12. But when you keep change flip, that becomes 24. And then you get sine. 14 minus 3 is 11 pi over 12, but then keep change flip, you get 11 pi over 24. And again, we don't even know what this answer would be, but you would leave it like this as well. All right, then that's pretty much all that you have to do. Hopefully that's enough examples to get you through. But of course, if you ever need any more help or more examples, please reach out and I'll help you out. Other than that, I'll see you in the next video.